This is a short video on graphing log functions. To start off with, I'm going to look at an example where I want to sketch y equals log to the base 2 of x. Of course, just like in any question with functions, this could also be written as f of x equals log to the base 2x. And as you would normally expect, you'll be given a range of values to use for your x. Then you evaluate those before you draw your diagram. Here I'm going to specify that x is between 1 and 16. It's important to notice here that my instruction is to sketch, so I am not going to have to get every single value of y. I'm just going to select the ones that work out quite nicely for me. And when I'm choosing which values to use, because I'm looking at log base 2, I'm going to choose values that are powers of 2. So I filled in my powers of 2, and now I'm going to substitute those into my function log to the base 2x. I can evaluate these, and my solutions are going to come out as 0, 1, 2, 3, and 4. I'm going to use these values now to go ahead and complete my diagram of my function log to the base 2x. So I'll draw my axes, I'll mark in the scales in those axes, and then I'll proceed to plot my points. So my first point is 1, 0. Here's my x value, and here's the corresponding y value. And so I mark that point in. My next point is the point 2, 1. Again, there's the x and there's the y, making the point 2, 1. I'm marking in 4, 2. 8, 3 and 16, 4. And now that I've marked all my points in, I'm going to join those together to make my curve. When I join the points together, it looks like this. This is the general shape of a logarithmic function. You can see that the slope starts off quite steep and then it levels out as it proceeds along through the graph. Note how the graph gets closer to the y-axis, to f of x, but it never actually succeeds in reaching the y-axis. And this makes sense if we think about the nature of our function f of x. If we think of the x value being 0, which of course represents our y-axis, we notice that it's actually not possible to evaluate this, because no matter what power I put on 2, I can't end up at 0. So this log to the base 2, 0 is undefined. What this means in terms of our graph then is that our y-axis is acting like an asymptote. Once I have a graph of a function like this, I can use it to estimate the values of the function at different x values. So for example, I could be asked to estimate log to the base 2, 15 from the graph. Now obviously 15 isn't a natural partner for 2, as in it's not a direct power of 2, but I can use the diagram to figure out what would be a reasonable estimate for this calculation. To do this, I'll go to the x-axis, since our function is log to the base 2x, and I'll go to 15 on this axis. I'll draw a line to my curve at this point, and then I'll just simply go across to the y-axis and read my solution off. In this case, a reasonable estimate for log to the base 2, 15 would be 3.9. And in fact, if you go to your calculator and type in log to the base 2, 15, you get a value very close to 3.9. In fact, you get 3.907. So to one decimal place, we're correct from our graph.